Okay, so this is problem number 15 from section 5.7. I wanted to break down this one because I thought it was a little challenging. In this section, we're talking about techniques for dealing with things where integration by parts isn't the easiest. It's not that it won't necessarily work, but it isn't the easiest. In this one, if we were to try and turn this into an integration by parts problem, we have t to the -3 times root t to the t squared minus 1 to the -1/2. And then you can set your u is equal to t -3rd, and then du would be, as you can see where I'm going with this, du would be -3 t to the -2 over -2, and dv would be t squared minus 1 to the -1/2, and the v would be the integral of that, which would be 1/2 t to the t squared minus 1 to the 1/2 over 1/2, and when you bring all that together, it just really looks like it's getting worse and not better, and sometimes that's the case with integration by parts. I haven't worked it out to see. I haven't worked it out using integration by parts because there is a better way to do it, and it's by using trigonometry. So, recall that one of the most fundamental basic formulas for trigonometry, one of the most fundamental basic trig identities is sine squared of theta plus cosine squared of theta is equal to 1. Well, if we have something here that looks kind of like that, we have t squared minus 1. So if we can get this in some kind of format that looks like something squared minus 1, and we can make a substitution, we can restate this integral in terms of trig identities and use different trig identities to solve the problem. So we have a couple of options. If we divide through by sine squared theta, then we have 1 minus cosine over sine is cotangent squared of theta is equal to cosecant squared theta. And then we can rewrite that as, well no, we can, so this looks an awful lot like, not quite, that's not quite something of trig function squared minus 1. It's 1 minus. And if I can bring it over here to the minus 1, I have minus cotangent. And I guess I could do a substitution for negative cotangent. But let's divide through by cosine and see if that gives us something friendlier. Cosine squared theta. Sine over cosine gives us tangent squared theta. And cosine over cosine is 1. And 1 over cosine is secant squared. Okay, if I bring secant squared theta over there, theta is equal to secant squared theta minus 1. I have something that looks exactly like that junk inside. So if I set the t to be secant theta, then I would have this, and it would just become the square root of tangent squared theta, which is very, looks easier to do. So let's try that strategy. So we're going to let t is equal to secant theta. dt then will be secant tangent theta d theta. So we're going to rewrite this in terms of the new, and before we rewrite, we have to redefine the limits of integration. So the lower limit will be root 2 is equal to secant theta. So to calculate inverse secant on your TI-89, you take the reciprocal, you do this cosine inverse, because secant is 1 over cosine of the reciprocal, 1 over root 2. And on the unit circle, 1 over root 2 happens at pi over 4. Right? That's one of the basic ones. You have 1, or not 1, but yeah, so it occurs at pi over 4, We can solve that, but that's just one of the standard ones that you should know. So the lower limit is secant inverse of theta, and is equal to pi over 4. And to find the upper limit, it's going to be on your TI-89 cosine inverse of 1 over 2. And at 1/2, we're at pi thirds. That's going to be pi thirds on the unit circle. Alright, cool. So let's rewrite this integral. The lower limit is now pi fourths. The upper limit is pi thirds. And this is rewritten as dt. dt is secant tangent. Secant theta, tangent theta, d theta. This will be over secant cubed theta times root secant squared theta minus 1. Even though it's bad form, I'm going to go sideways. Pi fourths to pi thirds. This is secant theta, tangent theta, d theta, over secant cubed theta. This is tangent squared root of tangent squared theta. That's just going to be tangent theta. So we have pi thirds secant theta, tangent theta, over secant cubed theta times tangent theta, d theta. The tangent thetas cancel out. This secant cancels out 1, that to leave us with a secant squared. Secant is 1 over cosine, so 1 over secant will be just cosine. That gives us pi over 4, pi cubed cosine squared theta d theta. Okay, so here we have a squaring function, so that means take the inner. If we do the substitution rule, we don't have a sign to work with. So what we want to do is we want to use an identity that gets rid of the squaring function, and that would be the half angle identity. So the half angle identity says that cosine squared theta is equal to 1 plus 2, or cosine 2x, or 2 theta over 2. And I will just check that really quick. Obviously there's so many angle identities, you don't have to know which one. The first one that you kind of think about is, the most basic one of all, which is sine over cosine squared plus sine squared is equal to 1, but that doesn't help us because we're trying to get rid of the squaring, and the half angle identity helps us with that. So then this becomes a really easy integral. Once we make that substitution, we have pi over 4 pi thirds of 1 plus cosine 2 theta over 2 d theta. And that's equal to pi fourths, pi thirds, 1/2, plus the integral of pi fourths, pi thirds, cosine 2 theta d theta. Okay, well this integral is just 1/2 theta. And we can evaluate that from pi fourths to pi thirds. And this we can use, this is just going to be 1/2, which is a jump inside. Integral of cosine is sine. So it's going to give us sine 2 theta. Oh, I forgot, I lost a 1/2 here from over here. So that's going to be another 1/2. 1/2 times 1/2, which is 1/4. So plus 1/4 sine 2 theta evaluate that from pi fourths to pi thirds. Okay, and let me check to see. Alright, cosine theta 2 theta. Okay. Alright, so the answer you should get after you calculate that into your TI-89 or whatever calculator you're using is pi 24 plus root 3 over 8 minus 1/4. Okay, and so, yeah, okay, that is the answer. So the integral before you evaluate, it should be 1 over 2 theta plus 1/4 sine of 2 theta. Okay, I hope this was helpful. Thank you.